This example, find the slope of the tangent line to the curve at the given point using implicit differentiation. All right, find the what? The slope of the tangent line, right? So I'm looking for slope of the tangent line, so I'm looking for the derivative basically, okay? So let's find the derivative with respect to x of this equation. Derivative with respect to x of x to the fourth plus the derivative with respect to x of y to the fourth is equal to the derivative with respect to x of 16. All right, what do we put here? 4x cubed, right? Because remember this x matches up with that x. How about this right here? This x does not match up with that variable y. So here's where the implicit differentiation comes in, right? We have 4y cubed, don't forget the times dy over dx. Now the derivative of a constant is 0. So let's find the derivative. So let's solve for dy over dx. So we have 4y cubed times dy over dx is equal to negative 4x cubed. Now if we divide both sides by 4y cubed, we get dy over dx is equal to negative 4x cubed over 4y cubed. Or what can we say? Dy over dx is equal to negative x cubed over y cubed, right? Now what is this? Yeah, it's a derivative. But it's a formula for the slopes of all the tangent lines, right? What do we want? We want the slope of the tangent line at the given point. At this point right here, right? Isn't this an x coordinate? And we could say that that's a y coordinate as well. So what I could do is I could say, okay, or what I want to do is say dy over dx whenever x is 1 and y is, whenever x is 1 and y is the fourth root of 15. Y is the fourth root of 15. All right, so let's evaluate my derivative when x is 1, y is the fourth root of 15. So we're going to have negative, instead of x cubed right here, we're going to say 1 cubed over, instead of y cubed, we're going to put in fourth root of 15. So what is that? 1 cubed is 1 times the negative is negative 1 over, now I could keep this way, I guess, or I could even write it as the fourth root of 15 cubed like that. And that'll be the slope of the tangent line to this curve at this particular point. So really the only new thing with this problem was just plugging in a y as well. All right, let's look at the last one we have for this section. It says, find the second derivative of y with respect to x. So it wants us to find second derivative of y with respect to x of 7y plus sine of y is equal to x. All right, so how do we find the second derivative? We find the first derivative and then take the derivative of that derivative. So I'm going to say, okay, the first derivative is going to be taking the derivative of 7y plus taking the derivative with respect to x of sine of y is equal to the derivative with respect to x of x, right? Well, this constant can come to the outside, and that's 7 times the derivative of y with respect to x. What's the derivative of y with respect to x? Remember, that's an understood 1 right there. So it's 1 times y to the 0 times dy over dx. How about this part? Remember, that's an outside, that's an inside, right? So what's the derivative of sine? Cosine at the inside times the derivative with respect to x of the inside, y. Now, why do we have to treat this with the chain rule? Because that y is different than that x. It's equal to derivative with respect to x of x is 1. What's y to the 0? That's just 1. So 1 times 1 times 7 is 7 times dy over dx plus the cosine of y times dy over dx is equal to 1. So let's solve for dy over dx. So we're going to factor it out of both of these terms right here. So dy over dx times 7 plus cosine of y is equal to 1, right? Now divide both sides by 7 plus cosine of y, and you have dy over dx is equal to 1 over 7 plus cosine of y. Whew, I'm done, huh? No. What did this say today? Find a what? Second derivative. I just found the first derivative. How do you find the second derivative? Take the derivative of this thing. Okay, so I'm going to take the derivative of dy over dx. The way I denote that is I say the second derivative of y with respect to x is equal to. Now, how do I take the derivative of this side? I can use the quotient rule. What's the quotient rule? Low, d high, right? Derivative of the numerator minus high, which is 1, d low, derivative of my denominator, all over low squared, all over 7 plus cosine of y squared. All right, so what is that equal to? Well, what is this? What's the derivative of 1? That's 0, right? 0 times this stuff just gives me what? 0 minus 1. What's the derivative of this part right here? Negative sine of y times dy over dx, right? How do I get dy over dx? That's a chain rule, isn't it? Inside is y, outside's cosine. So derivative of the outside is negative sine at the inside times the derivative of this inside. All over 7 plus cosine of y quantity squared. All right, let's clean this up a little bit. That's going to be positive sine y times dy over dx all over 7 plus cosine of y quantity squared. Now what is this? This is the second derivative of y with respect to x, we said, right? Now the only thing that's bugging me here is I have this dy over dx. I don't want this second derivative in terms of dy over dx if I can help it. Well, didn't we say that earlier in the problem? Right here, dy over dx is that stuff. So I'm going to make a substitution right here. I'm going to say this gives us the sine of y times, instead of dy over dx, what am I going to put in its place? 1 over 7 plus cosine of y. It's all in the numerator. It's going to all be over 7 plus cosine of y squared. Oh, now I got a mess, huh? What kind of mess I have? Fractions inside of fractions or fractions on top of fractions right here? Yeah, let me go ahead and write this over here, okay? Kind of out of room. So let's see, what do we have right here? We have sine of y times 1 over 7 plus cosine of y all over 7 plus cosine of y quantity squared. Just recopy. Now, how do I fix the fractions over the fractions here? Well, one way I could do this is I could multiply by 7 plus cosine of y here and here, and then 7 plus cosine of y would divide out right there. So let's do that. Let's multiply this by 7 plus cosine of y over itself. So that gives me the sine of y that comes down. Now this and this will divide out right there, right? How about at the bottom? What's 7 plus cosine of y squared times another 7 plus cosine of y? 7 plus cosine of y quantity cubed. And that's the second derivative of y with respect to x. There we go.